Hello, everybody. Here we are at 4.3. Can you believe it? I personally cannot. This is another form of the equation for a linear relation. We're used to seeing it in, let's say, our usual form has been y equals, blank x plus blank. And now we're going to be looking at lines. We've been looking at what they're called, like we can call this a sloped line. It's a P sloped line. You might also see it called an oblique line. It's a Q. So, if this is our x-axis and our y-axis, we've been seeing sloped lines. And another form that we might see is when we just have a value for x. So say we have x equals a. So if we had our, let's draw a better line. We have our y-axis and our x-axis. If we have x equals a, this means we are just going to have a value for a certain x. So it would be a vertical line like that if we just have an x. So this is our x-axis here, our y-axis, and this a here is a constant. And if we have, let's say, just y equals a, and again, I'm going to draw our x-axis or y-axis and our x-axis. If we have just values for y, it might look something like this. Okay, so it'd be a horizontal line. And the other form that we are going to come across, the notes are getting a bit all over the place here. But the other form we're going to look at is going to be ax plus by equals c. So that is what I would like you to write down. I would like you to write down all of this, but this is a very important part, okay? Ax plus by equals c. So in our notes, the things that we should have are that sometimes we're just going to have a value for x. That's going to make a vertical line. Sometimes we're just going to have a value for y. That's going to make a horizontal line. And that our sloped line, or sometimes called an oblique line, and that this is the other form that sometimes we will see a linear relation in. You can tell this one's a linear relation because they have both values for x and y. And I hope that'll make a little bit more sense as we go through the notes. So let's look at the first one. Does each equation describe a vertical, a horizontal, or an oblique line? Describe each vertical or horizontal line. So here we have that y equals 4. So we could just write in each of these that y equals 4. Doesn't matter where we are, y is going to equal 4. And here, over on x, and I'll draw this now. So let's go y for 1, 2, 3, 4. It's going to be that line right there. That's A. It's hard to think or to kind of like conceptualize what x equals. But the thing is, there's currently no restrictions on x. It's not in our equation, so there's no kind of like limit on what x can be. So it could be, -2, -1, 0, 1, 2, 3, 4, 5, 6. It could be 700. There's no restrictions on x since it's not like described by our equation. But it does mean that y is going to be on 4 and will always be on 4, and it's a vertical line. Though it should be a straight vertical line, mine's just a little jagged. So here, again, we just have x's, but it's not as clear as this one what x is equal to. So we have to kind of solve this equation first. So let's go 2x plus 5 equals 7. Let's get the x by itself. So let's subtract 5 from each side. We get 2x equals 2. To get the x by itself, let's divide by 2 and divide by 2. So we get x equals 2 over 2 is 1. So that's going to equal 1 there, 1 there, 1 there, 1 there, 1 there, 1 there, 1 there. And again, we have no restrictions on this. -3, 0, 3, 6, 9, 12, 15, doesn't matter. Let's put x at 1. And there it is. It's a vertical line. So that's B. Let's look at this one. Okay, cut off, but we're back in business. For this one, we have both x and y, so we know it's going to be a sloped or oblique linear equation. And I think it's best to start with putting zeros in each of these to solve for the other one. So if we do, for example, like 2, so let's put a 0 here. 2 times 0, subtract y equals 6. We essentially get negative y equals 6. We don't like to have a negative variable. This doesn't say negative y, so we have to divide by -1 on each side. Remember, there's like an invisible coefficient or invisible 1 right there. So if we divide by -1 on each side, it makes our y positive, but it will make our 6 into a -6. And then if we input where we're at, where we put a 0 into the y, we get 2x, subtract 0 equals 6. So 2x equals 6. Divide by 2. Divide by 2. We get x equals 3. So when y is 0, x is 3. And then you can see a little pattern. So we're going up by 3 on this side. So if we go to 6, we could go to -3. We are going up by 6 on this side. So that's going to be 6. We could go -12. So now let's plot them. If we are at, let's see, -3x, 1, 2, 3. We are at -12y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, way here. If we are at 0x, we're at -6y. 1, 2, 3, 4, 5, 6. If we are at 3x, 1, 2, 3, we are at 0y. 1, 2, 3. And if we are at 6x, 1, 2, 3, 4, 5, 6, we are at 6y. 1, 2, 3, 4, 5, 6. So our line will look something like that. Okay, go that way, go that way. That's C. Okay, let's look at our next ones. And again, yeah, I would start by inputting 0. It's easier to kind of solve these things when you get rid of one of the variables, essentially. So let's look. I'll get my red highlighter out here and just highlight the lines. That's the line right there. And in this one, that's the line right there. So what does this describe? Well, there are only y values. Okay, so there's only y equals 2. It only touches x here. So there's only y values. So let's go y equals 2. Here we have a vertical line. It's at -2x, and it does not touch, not over here. So we're going to go x equals -2. Okay, very good. So there's only one variable, you know it's going to be a vertical or horizontal line. It's a little bit counterintuitive that the y is horizontal because we're used to the x being the horizontal axis. And yeah, that the x, when there's only x values, then ends up being a vertical line. So it's a little bit counterintuitive, but maybe you could remember that it's like the reverse. And let's do this last one. For each equation below, make a table for the given values of x, graph the equation. So they give us these values of x right here, and then they want us to graph it. So they want, I don't know why they gave us all this room, but -2, 0, and +2, -2, 0, and +2. So let's just input these in and get the values. So let's go 3 times -2 plus y equals 3. So that's going to be negative 6 plus y equals 3. Oh, that's a 3, not a y. Let me scroll. And then to get the y by itself, we need to add 6 on each side. So we get y equals 9. So that's for negative 2. Then when it's 0, we have 3, 0 plus y equals 3. So that's kind of ends up being y equals 3. And now I think we can see a bit of a pattern. As this goes up by 2, this goes down by 6. So that ends up our next one's going to be at negative 3. You could quickly confirm, okay, so that would be 6 equals plus y. You've had to subtract 6 from each side, and that makes sense. Let's do this next one right here. So we have, let's start with our negative 2, subtract 2y equals 8. To get the y by itself, let's first start by adding 2 to each side. We get negative 2y equals 10. And now let's divide by the negative 2 on each side. Y equals negative 5. So that's that one right there. Let's do another one. 0 subtract 2y equals 8. So that kind of, forget about that. Let's divide by negative 2 on each side. And we get y equals negative 4. Negative 4. So now you can see the next one's going to be negative 3. See the pattern. We could check, does that kind of work? 2 subtract 2y equals 8. We'd have to subtract 2 from each side. You get negative 2y equals 6. Divide by negative 2, divide by negative 2. And yeah, you'd get negative 3. Now let's plot it. I'm going to use some colors. Let's do this first one. We are at negative 2x. And a positive 9y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Way up there. Next, we're at 0x and positive 3. 1, 2, 3. And we are now at 2 and a negative 3. 1, 2, 3. Okay, there's our first line. Something like that. And our next one, I'll use another color. We are, again, let's start at negative 2x, and we are at a negative y this time. 1, 2, 3, 4, 5. Now we're at 0, and we're at a negative 4. 1, 2, 3, 4. And our last one, we're at a positive 2, and we're at negative 3. 1, 2, 3. Okay. And that looks something like, there you go. Okay, so again, we are using what we know to find out what we don't know. So we knew these values, we input it into the letter, and we solve for the unknown. Again, we just input what we know the values of x, we input it into where the x is, and we solve for y. We solve for what we don't know. And the important things to remember, if you have both variables, it's going to be that sloped line or the oblique line like this. If you have just the y, it's going to be a horizontal line. If you have just the x, it's going to be a vertical line. Okay, thank you so much.